Hello viewers, welcome to another session of Big Why Physics. Today in this video I'll be discussing few important and interesting concepts of kinematics. Well, you can see the heading is equation of trajectory. Of course you can guess that it's from the topic of projectile. So without further wasting time, let's get started. Now, how we define the equation of trajectory? First we consider a coordinate system. So let this be my coordinate system. Using the white dot, indicating the path of projectile, and the red dot, as I am showing, is the initial position of the projectile during the motion. Right? This is my y-axis. This is my x-axis. So, at a given instant, can we write as a function of time the x-coordinate and the y-coordinate? That is, x as a function of time and y as a function of time. If we try to write x as a function of time, suppose the initial velocity is v and it's inclined at an angle theta naught, or let it be theta only with respect to x-axis. Then what will be the value of vx? Vx would be v cos theta, vy will be v sin theta. So can I say that x as a function of time is equal to vx cos theta into t? Now second thing is, what is y as a function of time? It will be, sorry, it will be v cos theta into t only. So the y as a function of time will be vy into t minus half gt square. What is vy? Vy is v sin theta. Putting it, you will get v sin theta into t minus gt square by 2. Putting t is equals to x by v cos theta. Now t is equals to x by v cos theta. Parametric equation used, as you know. So y as a function of time, or y you can write as a function of x in this case, will come out to be x tan theta minus gx square by 2v square cos square theta. Right? Now what I'll do is, taking out x tan theta in common, you will get 1 minus x by r, where r is the range of the projectile. That is, capital R is equals to 2u square sin theta cos theta by g, and that's the final answer. So nothing special in it, because just another stuff which is given in the modern textbooks. Right? Now I'll be giving you few important and interesting results regarding it. So let's get started. Now first question is, if you want to maximize the area of projectile between ground and the trajectory, what theta will you choose? What should be theta? That is the initial angle with respect to ground, and velocity of the projectile at the initial moment is given as v naught. Okay. Now you have to basically find theta in this case. So pause the video, give it some time to this problem. Okay, let's get started. To do this problem, we'll be just using some basic concepts of differentiation and some amount of integration also. Well, you know the equation of trajectory can be written as y is equals to x tan theta into minus gx square by 2u square cos square theta. Seems to be lengthy because we need to integrate it from 0 to r and all this. Cut it out, take the x tan theta out, and just multiply it with 1 minus x by r. Just this is the required factor. Now you have to perform the integration from 0 to r. If you perform, you will get that the area A is proportional to tan theta into r square. That is, it will be tan theta into r square, some into some constant c. Okay. Now r square can be written as something as another constant c dash into sine square theta cos square theta into sine theta by cos theta. Cancelling on cos theta, you will get sine cube theta into cos theta. That is, area is proportional to sine cube theta into cos theta. You know one thing, that sine square theta plus cos square theta is equals to 1, right? Now I'll be giving you two methods to maximize the area. That is, a is equals to k times sine cube theta by cos into cos cube theta. You can maximize the area and find the required value of theta in two methods. First method is basic differentiation. Just put dA by d theta is equals to 0. You will get 3 sine square theta cos square theta minus sine cube theta into sine theta is equals to 0. From here you will get tan theta, tan square theta is equals to 3, or tan theta is equals to plus minus root 3. We'll take the plus sign because we are dealing with positive angle theta only. So you get a surprising result that the angle at which we should project, that is theta is equals to 60 degrees. Well, it is one of the standard trigonometric angles we generally study while we memorize the chart of the trigonometry values, right? So something interesting we got. Another method. There is a second method to do this, that is AMGM. So I can say that 3 sine square theta, 3 into sine square theta plus 3 cos square theta. Just see how I am putting the brackets. Okay, just see how I am putting the brackets, because the way I will put the brackets will also indicate the way I will be solving it. So I can say this will be 3. So sine square theta plus sine square theta plus sine square theta plus 3 cos square theta is equals to 3. Now we'll be applying AMGM. Now AMGM says that the sum by 4, because the number of terms I am considering is by 4, is greater than equal to the product of each of the term, which will come out to be sine to the power 6 theta into 3 cos square theta whole to the power 1 by 4, or you can write that it is equal to sine cube theta 3 into sine cube theta cos theta whole to the power 1 by 2, and here the 3 outside which will come will have 3 to the power 1 by 4th power, right? Got it? So basically we are interested in maximizing this term, right? Then you know that if the aim is equals to gm, then each of the individual terms must be equal. So I can say that sine square theta is equals to 3 cos square theta. From here we will get tan square theta is equals to root 3. That is tan theta is equals to root 3. From here theta is equals to pi by third, or 60 degrees. So this is an important thing I'd like you to know, that to maximize the area, you have to project the projectile at an angle 60 degrees with respect to horizontal. Well, take it as an exercise that what will be the required area. You need to just put the values and find it. So you can write the answer in the comment section. Okay. So let me ask another question, but this will not involve the equation of trajectory, or maybe you can try to involve the concept of equation of trajectory. Suppose the question is, let me read it out, that if you are required to project the projectile and you want to maximize the distance, then the thing is that the projectile, the trajectory in which the initial and the final velocities are perpendicular, then this distance is said to be maximum. Hope you got the question. Let me explain it properly. Okay, it says that suppose that you have an incline, you have an inclined plane. Okay, you are given an inclined plane and you are said to throw a projectile from the bottommost point, that is the red dots indicating the projectile, with velocity v naught. Then you have to tell me the maximum range which is possible on the inclined plane. Okay, and what will be the conditions, right? So you can either use the concept of equation of trajectory, then maximizing the angle theta with the intersection y is equals to mx, or y equals to tan theta, where theta is equals to this angle. So y is equals to x tan, let it be beta rather, instead of being theta, tan beta, and this is theta, or you can write it as mx. For now I'm considering mx. Then you have to tell me the conditions that so that the projectile covers the maximum distance on the incline. First method is equation of trajectory. You can take it as an exercise. Second method, which I'm gonna show you, is a little interesting one. Suppose now you change the coordinate system. Now you change the coordinate system. You consider this as the x-axis, this as the y-axis, and try to maximize this in this case. Okay. Then if you try to maximize, you'll get some result that y as a function of t, x as a function of t, both will be quadratic, and both then using parametric differentiation, then you'll be trying to find the required values. So this is another method. Third method I'll be using is conics geometry. Third method will be conical geometry. Okay. Suppose at the end it reaches, will have some velocity u, then it says that u and v should be perpendicular, because you know that the focal point will be somewhere at this point. The focus of the parabola, that will be f, will be somewhere on the incline, so that v naught square by 2g plus u square by 2g will be maximum. The length is maximum only if the focus is on the inclined plane. Now observe that AB, the point intersecting the incline and the point from which the projectile is being projected, is a focal chord to the parabola, right? If you know one property of a parabola, that is, if you have a parabola and this is the focus, and this is one of my focal chord, then the tangent to the parabola at the focal chord subtend a right angle and intersects at the directrix. This is a very famous property of parabola. This means that the tangents drawn along u vector and v vector would be meeting at 90 degrees on the directrix. Hence, v vector and u vector would be at an angle 90 degrees when the projectile has to reach the maximum height on the incline. So, this is a very important theorem, you must know about it. And well, for your convenience, I am also giving you the values. So generally you can also derive it, take it as an exercise. So the maximum range in this case is given as u square by g 1 minus sine beta, where beta is the angle with respect to the incline. Okay, hope you understood it. Take this as an example to derive. Let's proceed to the next example. So this is another problem. Well, this problem you can see in one of the famous universities textbook also. It's from David Morin. The other two problems were also from David Morin. And this problem is actually a little overhyped because of its huge calculations. Okay, so let's get started. The question basically says you have to maximize the length of the trajectories. The first question will come in your mind that how will write the length of the trajectories. Then one thing you must know, that suppose you have a curve y is equals to f of x, and you consider a differential element. You can assume this to be a differential right triangle where this is dx, this is dy. Then you can write that the length, that is dl, will be under root dx square plus dy square. Now taking out dx common, you'll get it to be dx into under root 1 plus y dash whole square, where y dash is equal to dy by dx. So this is a very famous important result, and if you want to find length, just integrate, right? So this is basically my result. Now if you want to tell me what will be dy by dx, let me explain. What will be dy by dx? You know y is equals to x tan theta minus gx square by 2u square cos square theta. So dy by dx, that is y dash, is equals to tan theta minus gx by u square cos square theta. Now I'll be using one small substitution, that is I'll be putting y dash to be u. Then what will be du? Du can be written as minus g dx by u square cos square theta. From here you'll get dx to be minus u square cos square theta by g dx du. Basically we are asked to integrate 1 plus u square du, that is cos square theta du by g minus u square. Yeah, it will be, sorry, we are already substituting one b. That will be v. Okay. Otherwise there would be mess up with variables. We'll mess up eventually. So then taking all the other terms outside, you get v square cos square theta, and taking, basically we are interested in magnitude and we are mostly interested in theta, so I'm keeping other terms as constant. So it will be under root 1 plus u square du. So doing the indefinite integral, will end up with c cos square theta into 1 by 2 u under root 1 plus u square plus 1 by 2 ln u plus under root 1 plus u square. Now can you tell me the initial value of u? That is, when x is equals to 0, u is equals to tan theta. When x is equals to the value that is range, then u is equals to minus tan theta, right? Just putting those values, since you got minus v square by 2g, basically initial angle will be tan theta, final angle will be minus tan theta. That is the value of u, rather to say. Take one minus sign and changing the limits signs, you will get v square by g cos square theta 1 by 2 into 2 tan theta sec theta plus ln tan theta plus sec theta. Okay. Now finally you will end up with some interesting result, that is the length as a function of theta is proportional to sine theta plus cos square theta ln tan theta plus sec theta. Yeah, pretty interesting. Now we have to now differentiate L with respect to theta. Dl by d theta is equals to 0 for maximum length, right? Now converting this tan theta plus sec theta into 1 plus sin theta by cos theta, theta by cos theta. It will involve pretty heavy calculations rather. So you will get cos theta minus 2 cos theta sin theta ln 1 plus sin theta by cos theta, and plus cos square theta into cos theta plus by 1 plus sin theta, and rest of the terms, that is sin theta plus 1 by cos square theta, cancelling out all the non-required terms, and here we'll end up with 2 cos theta is equals to 0, cancelling the 2 cos theta also. We'll get sin theta into ln 1 plus sin theta by cos theta is equals to 1. Now we are asked to find the required angle. Just the required angle is theta naught. Let the solution be theta naught. So it will be sin theta naught into ln 1 plus sin theta naught by cos theta naught. Well, if you, they have actually even given the some kind of approximate value of the theta. If you try to solve it by using regression, all those other method of calculation which I don't know actually. So they tried to evaluate using graphical methods, all those. Then they got theta naught is approximately equal to 56.5 degrees. This is some kind of a non-standard value. Unlike the maximizing the area question, this one is a little non-standard one, right? Hope you got it. So that's it. That's it for today's video. So thank you and have a nice day.